Hello there, welcome to part 12 of learning everything we can learn from VisionOS Documentation by Apple. Here we have the next article, placing content on detected planes. We're going to detect horizontal surfaces like tables and floors, as well as vertical planes like walls and doors. Flat surfaces are an ideal place to position content in an app that uses a full space in VisionOS. They provide a place for virtually 3D content to live alongside a person's surroundings. Use plane detection in ARKit to detect these kinds of surfaces and filter the available planes based on the criteria your app might need, such as the size of the plane, its proximity to someone, or a required plane orientation. Here is a sample app. We have several objects here that is painted in colors. The floor is painted in yellow, table is in red, and the walls are in blue. Use RealityKit anchor entities for basic plane anchoring. If you don't need a specific plane in your app and you're rendering your app's 3D content in RealityKit, you can use an anchor entity instead. This approach lets you attach 3D content to a plane without prompting the person for world sensing permissions, and without any particular knowledge of where the plane is relative to the person. The following shows an anchor that you can use to attach entities to a table. It goes like this. We have an anchor entity function, it looks like. It takes in a enum called plane, which has the variables dot another horizontal enum and the classification of a dot table enum with a minimum bounds of 0.5. I bet that means meters. And the anchor entity don't let you choose a specific plane in the person's surroundings, but rather lets you ask for a plane with certain characteristics. When you need more specific selection or real-time information about the plane's position and orientation in the world, use ARKit session and the plane detection provider. Okay, let's configure an ARKit session for plane detection. Plane detection information comes from an ARKit session. These configured to use a plane detection provider. You can choose to detect horizontal planes, vertical planes, or both. Each plane that ARKit detects comes with a classification, like plane anchor.classification.table or plane anchor classification.floor. You can use these classifications to further refine what kind of plane your app uses to present content. Plane detection requires ARKit session authorization type .world sensing authorizations. The following starts a session that detects both horizontal and vertical planes, but filter out planes classified as windows. As before, we're going to create an ARKit session, and we're going to have a plane detection provider that's both horizontal and vertical. Next, we're going to start running this session with the plane data that we would like. Now we have a async sequence of plane data anchor updates that will update, and we'll skip any plane that is of a window type. Upon any other event, we're going to use either .add or .update, and we're going to update the plane and update the anchor. I bet this function in the previous application where we have different colors for different types of planes will map those colors to those planes. And if we don't see these planes anymore, we'll remove the plane. Next, let's create and update entities associated with each plane. If you're displaying content that needs to appear attached to a particular plane, update your content whenever you receive new information from ARKit. When the plane is no longer available in the person's surroundings, ARKit sends a removal event. Respond to these events by removing content associated with the plane. The following shows plane updates that place a text entity on each plane in a person's surroundings. The text entity displays the kind of plane ARKit detected. Here's the entity map. Here's update plane, as we spoke about before. Here we are, if entity ID is equal to nil, let's create a brand new text for this plane. This is generate text, anchor.classification.description, and entity map with the ID equals entity. Now we have attached this to our map. Root entity dot add child of entity. Entity map ID dot transform, and this this makes a little transform motion to this particular anchor, to this plane. Now here we have removal. If it is no longer in view, we're going to remove this ID from the parent and remove the value. All right, with that, we have looked through all of this code. I think let's, if there's an opportunity, let's try to find this code in the previous sample code and let's see what we get. All right, jumping into the code, we see the process reconstruction updates function, which runs async. This is a little different from our sample code earlier, for this is going to be using a scene reconstruction anchor update that is async, where anchor updates sequence is an async sequence, as you can see. Async sequence of all anchor updates. So I believe this is going to be a little faster than our sample code earlier, which is in sequence. Now, other than that difference, it is exactly the same, where we're going to take in an ID, we're going to find the entities, we generate a mesh, we're going to give it some components, in this case, a transform, collision, and physics component, and input target component, so that we can knock over some blocks on it. Next, we're going to update that plane to make sure that if there's any changes, we're going to update that. And lastly, we're going to remove it once it is out of our view. And with that, we remove it from our dictionary. Our dictionary is right here, UUID with a model entity, similar to before. And with that, I think we have gone through everything we need to go through for this article, and we'll be ready to move on to the next article tracking specific points in world space in the 13th video.